Hello, fellow mathletes. I am a famous physicist, and I am here to teach you about the wonder of the area in between two curves. Now, first and foremost, we need to understand the formula that helps us find the area in between two curves. The formula is the integral from a to b of the top function minus the bottom function. And the reason this formula works is because if we take the area underneath the top function, it will look similar to this triangle right here. Take the area under the curve of the bottom function, it will be this area right here. And if we take the area of the top function and subtract the area of the bottom function, we'll get the area in between the two functions. Okay, so now I'm going to show you an example of how to use our equation here. Here's a graph of x, and the graph of x squared between 0, the domain is 0 and 1. Now what we're going to do is we're going to go 0 to 1, take the integral from 0 to 1 of x minus x squared. Now, that will turn out to be 3. I'm not teaching you how to do integrals, I'm just showing you how I came to my conclusion. 1/2 minus a third, which is 6. There. That is the area in between the two curves from 0 to 1. Okay, now sometimes we have to find where if two equations cross more than once, like right here. Well, we have to find the area. We have to change our formula. We can see the functions switch from being on top to, they switch places from being on top to bottom to bottom to top. So, to do this, we are simply going to find when the two equations equal each other, because that is where they will cross. Since we have sine of x and the negative sine of x, we know that they will both cross each other when they equal pi and 2 pi. So, what we're going to do is we are going to start. We know that sine of x is on top from 0 to pi. So what we're going to do is we're going to draw the integral from 0 to pi of the sine of x minus the negative sine of x. And then after that, we have this whole integral here. We are going to add the integral from pi to 2 pi. But now we have this equation negative sine of x on top of the equation sine of x from pi to 2 pi. So what we're going to do is we're going to have negative sine of x, sorry about that, the integral from pi to 2 pi of negative sine of x minus sine of x. And when we add these two together, we'll get the area in between, we'll get all the area in between both of these curves.
Now.
Okay, now. Okay, so this is gonna be real easy. This isn't hard at all. What we're gonna do is sometimes our equations here won't be in terms of x. They'll actually be in terms of y, which just turns our whole axis into something you couldn't even imagine. So what we're gonna do is it's really simple. We're gonna get a new equation, which is gonna help us find out the area in between these two curves, seeing as neither one is really truly on top of the other. And what we're going to do, the new equation is really simple. It's similar to the other one, the integral from a to b of the right function minus the left function. Now, when we use an integral for an equation like this, the blue function in question, negative y minus 2 squared, would be the function on the right, while x minus y squared would be the function on the left. as you can see, take the area of that function, the area between these two curves would be this. Use that formula, which, when we use the two equations in it, it will look like this. From 0 to 2, right function would be negative y minus 2 squared. And the left function, subtract, would be minus 1 squared. That would give us that area right there, because when we subtract the right function from the left function, in relation to the axis, it's going to makes that function right there, the right function, as relative to the y-axis, is actually on top of the other function, which is the left function, which is on bottom. It's very, very easy. Okay. It's very easy. You got it? You understand? Okay. Alright, was it good? Ready? Alright. It's time for a quick review of everything we've talked about involving the area between two curves. Alright. First, we got into the formula from A to B. Take the integral from A to B of the top function minus the bottom function. That will give us the area between any two curves. Now, if the curves cross streams at any point, we're going to want to take the first integral from A to B of the top minus the bottom and we're going to add an integral from B to C of the other function, and we're going to assume that B is the point where the first function equals the second function. Also, if you want to find the really hard thing to do to find the area of curves that are in terms of y instead of x, so for equations such as x equals y squared and, I don't know, x equals negative y minus 3 squared plus 7 halves times pi, or so, whatever you want to do. For this random these two equations, you'll find the area in between them. You're simply going to do the same integral, a to b, of the right function minus the left function. Because, and on the axes, if you have these equations here, it will switch over to the y-axis because you're doing this in terms of y instead of in terms of x. And that is how you find the area between two curves.